Let us discuss static versus dynamic memory allocation. For that, you should understand memory. This is main memory. Just you think, this block represents as memory. Memory is divided into smaller address unit that is called bytes. Let us assume these boxes are bytes. Every byte is having address. Address is this 0, 1, 2, 3, 4, 5, like this. Now see the diagram. Diagram is two dimension, but address is single dimension. So address are linear, not like coordinate system XY. So I'm assuming my main memory is 0 to 65535. Here is 0 and here is 6, 5, 5, 3, 5. 0 to 65535 mean 64 into 1024 equal to 64 kilobyte. Nowadays, you are using 8 or 16 or 32 GB RAM. To understand, I am taking 64 KB memory. Start from 0 and last address 65535 bytes. Every byte is having address. If you have larger size RAM is 8 or 16 or 32 GB. Then entire memory not used as a single unit, that is divided into manageable pieces, that is called segment. Usually 64 KB, so size of the pieces 64 KB. Next, how the program utilize main memory. Main memory divided into mainly three sections: stack, heap section and code section. I will discuss static variable and global variable later. If I run the program, then program come to main memory from hard drive. So the area that occupied main memory, that section called code section. That would may not fix. It depends on size. When it is loaded, then CPUs start executing this program. Remaining memory divided into stack, and heap section. Now let us learn how this stack and heap works. This is my example code, sample code. Main function has two variables, integer a and float b. Integer a, assume here 2 byte, float b 4 byte. One should be noted, in C or C++ programming, number of bytes taken by integer or float depends on compiler, OS, operating system or hardware. We say mostly depend on compiler. If you take Turbo C, which is 16-bit compiler, it takes 2 bytes for integer. If you use Dev Studio or code block, then integer will take 4 bytes. It's a 32 bits compiler, so integer can take 2 bytes, also 4 bytes. So I'm assuming integer 2 byte here and float 4 byte here. So 2 plus 4 equal to 6 byte. So 6 byte allocated inside the stack. This block of memory that is belongs to main function that is called stack frame or activation record of main function. So whatever variable should declare inside the program or function, the memory for this variable created inside the stack. So allocated inside stack. The portion of memory inside stack that is called activation record. Size of the main memory required the function decide by compile time only. This is static memory. So what is static? Size of the memory required during compile time, that is static. It is before runtime. Main function is having two variables a and b and called it function 1. Function 1 is having one local variable x and calling function 2 and passing parameter x. Function 2 is taking parameter I and having own variable a. Then how the memory allocated for this function? Let us look at this. First, when I run this program, machine code is copied in the code section, this section. So I write all function in code section. Let us start executing. When the program start executing, it will start from main function. So memory for the variable a and b allocated inside the stack, like memory for the variable a and b allocated inside stack like in a single block. A and b. Main function called function 1, then control goes to function 1 like this. First thing, inside the function 1, the variable declared is integer x. Then x allocated in another block of the stack. This portion belongs to function 1. Topmost activation record belongs to current activation or control function. Function 1 called function 2. Then control goes to function 2. Function 2 is having two variables. One is parameter and another local variable. So one reason allocated for that variable. That is I. Another section, local variable a. That region belongs to function 2. Now presently function 2 running, and topmost activation record is function 2, currently executing function 2. So we start from main function, then function 1, then function 2. Now let us continue execution. Function 2 is currently executing function. When function 2 finishes or terminated, then control goes back function 1. After this point, it will come back to function 2 statement of function 1. What happened? Activation record of function 2. This will be deleted. When function 1 finish, then control goes back to function 1 statement of main function. Activation record of function 1 will be deleted. So record of this function 1 remove from stack. Main function also end, and activation record of the main function removed from stack. The way activation record created like this and deleted like this mechanism is called stack. Activation record created top, then top, top, and deleted from top, next top, then top. That's why this section of memory we have like stack during the function call. So this portion of memory named as stack. That's all. This is the main memory used. Stack used during the function call. One important thing is to observe how much memory is required by the function depends on number of variables and their size. This is decided by compiler only. This memory automatically created and automatically destroyed. So programmer doesn't have to do anything for allocation or destruction. Just a programmer has to declare variables. Next topic, heaps, and see how dynamically memory allocation.